Hi friends, welcome back. Good evening. So let us start with the it leads to the cylindrical coordinate system. And there is one more coordinate system, what is called a spherical coordinate system. Number 3. Spherical coordinate system. Here the coordinates are r comma theta comma phi. And here the limits are r is ranging from 0 to pi. Theta is ranging from 0 to r is ranging from 0 to infinite. Phi is ranging from 0 to 2 pi. R is radius of the sphere. Radius of sphere. What is theta? Theta is elevation angle. Dinesh, there may be problem from your side for your audio. Is there any audio problem, friends? No, there is no audio problem. Audio is clear. Okay, theta is the elevation angle. Phi is azimuthal angle. Clear? Yes. I need to justify what those angles are. Okay. Now here will be using what is called a right-handed and orthogonal coordinate system. What it is? A right-handed. Orthogonal. The meaning of orthogonal here, r is perpendicular to theta is perpendicular to phi. Yes, and then here it is r, here it is theta, here it is phi. These three are orthogonal set. Fine. What does that mean? Is phi cap. Theta cross r is minus phi cap. Clear? Yes. Fine. Let us try to. This coordinate system is developed by assuming this unbound three-dimensional space as a sphere. I need to draw. Let me turn the page here. I need to justify all the points. Step. I will. What is the note? Same thing. Angle direction is tangent direction at that point. Angle direction is tangent direction at that point. Clear? Okay. Let me turn the page here, beta. Now I need to draw the entire sphere here like this. But if I draw the sphere like this, that will not make any sense. That is the reason why. What I'll do, I'll consider only the octant of the sphere. That means 1/8 of the sphere I'm going to draw. Octant of the sphere. If you consider the sphere like this, if you cut it like this, cut it like this, cut it like this, 3 cuts will lead to 8 pieces. I'm going to draw one of the piece here. Okay, octant of the sphere. But I'll ask you to visualize the entire sphere. You need to visualize the entire sphere. Okay, yes. Let me draw the right-handed coordinate system. Whenever I draw the coordinate system, undoubtedly it is a right-handed coordinate system. There is no doubt in that. You need to cross-check that. Clear? Yes, observe here carefully. Here it is x-axis. Here it is y-axis. Here it is z-axis. That is the thing. Okay, what is this one? It is not like this. Let me show you. Let me put some dotted lines here. Why I'm putting this dotted line? To create the feel that it is a three-dimensional one. Okay, there was small technical error. Fine. So this is a octant of the sphere, but I'll ask you to visualize the sphere. I'll ask you to What you want to say, Mr. Attendee? So, octant of the sphere, but I'll ask you to visualize the sphere. Visualize the sphere. Okay, I want to locate some particular, please be focused. I want to locate some particular point P here, beta. If I want to locate some particular point P here, it will have 3 coordinates. What are they? Point P will have 3 coordinates. They are r comma theta comma phi. What is this r is, beta? R is a radius. What is theta? Theta is an angle made with respect to z axis. If I drop this point onto the xy plane, listen carefully. I'll call here it is a O. This one is P. This one is O, A. The angle made with respect to the x-axis is phi. Okay. So here, this is the R. Observe here video. This is R. This one is the theta, beta. This one is theta and this one is phi. Clear? I'll ask a very basic question. Is that OP and OA are same? If you can answer this one correct, it implies that you have visualized it correctly. I'll repeat my question one more time. Is that OA and OP are same? No. They are not same. OA is a shadow of OP. I'll draw only that section separately. Try to visualize this one properly. Here it is Z. Here it is OP beta. Here it is OA beta. OA and OP are different. What is the angle made with respect to Z axis is theta. If I drop this one point onto the x1 on this one, here it is, this is R. Here it is R cos theta. Here it is R sin theta. This is R. Observe here, video. This is R. If I drop this point onto the xy plane, this is R. If I drop this point onto the xy plane, this is OA. Angle made with respect to x-axis is phi. Angle made with respect to z-axis is theta. Clear? Observe here. Let me go back. Try to justify the limits here. Try to justify the limits here, beta. What is R? R is a radius. Very good. Can you see this corner? Yes. Yes. Observe here. R is a radius, beta. Theta is like this, elevation angle, and phi is like this, azimuthal angle. To justify these limits, I'm going to give one simplest example, which is very convincing. It is defined like this with respect to x-axis, with respect to y-axis, with respect to z-axis. One of your friend is asking why only with respect to z-axis. It is just by convention. We focused here. I'll give one very convincing example. Suppose if you want to see a star in the sky, how do you see? Generally, you'll see like this, or like this, or like this. Want to show with the help of a spherical coordinate system. Observe here carefully. This will going to justify the limits. I want to see the star is somewhere here. I want to see the star. So what I will do? I'll rotate my head like this. What is this angle? This angle is phi. And what is this angle? This angle is theta. And the distance from eye to star is r. So this is phi, this one is theta, and this one is r. Suppose if I want to see a star from here to here, somewhere here. Can you see my hand? Here to here. So what I'll do, my head is like this. I'll fix the theta, but I'll going to change the phi. Yes or not? But I'll not do like this. Yes. So what I mean to say here is, observe this action, what I'm going to do. Suppose if you want to see the star in the sky in this section, this is theta. Theta is only from 0 to 180 degrees. And this is phi beta. And this is theta. And this is phi. This angle is phi. This angle is theta. This angle is phi. So this angle is phi. What I'm rotating. And this angle is theta beta. Phi, theta, phi, theta, and so on. So the theta, listen carefully. Theta is, that is how it is defined. Theta is only from 0 to 180. 0 to 180. But phi is from 0 to 360. Clear, beta? Yes. Okay. Fine. Thank you. It is not a yoga session. Sorry. It is not a yoga pranayama. I am not even this. Okay. But ultimately, you need to convince. You have to visualize. Whatever I do in the classroom, that is for you. It may be funny. It may be funny, but it will going to help you. Fine, beta. Yes. Jokes apart. Phi is theta. Phi is from 0 to 2 pi. Theta is only from 0 to 180 degrees. Like this. 0 to 180. Like this. 0 to 180. This is phi. This is theta. That is how it is defined. Clear, fine. Now observe here. I want to decide the directions of unit vectors. What is the direction of the unit vector? Suppose if I want to decide somewhere here. R is radially outwards. Theta is tangent at this point. Phi is tangent at this point. What I mean to say here is, let me show you. R is radially outwards. Theta is tangent at this point. Phi is tangent at this point. Clear? Yes. Fine, beta. Now let me turn the page here. I'm going to draw a top view here. Let me show you the different unit vectors separately. Then I'll going to come to that representation. So the R is radially outwards. Theta is like this. Phi is like this. Tangent like this. Clear? Either way. See here. I'm going to turn the page. I'm going to draw a top view here. Let me go back. If I see a top view, what I'll notice? I'll notice the XY plane. It is a sphere actually. XY plane, I'm going to notice the circle. Yes. So here it is. XY plane beta. Here it is X, here it is Y. Z is outside the board. If I see a top view, you're going to find a circle. Clear? Yes. So here it is OA. Angle made with respect to x-axis is phi beta. So the phi angle is like this. I want to decide here. 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 What is the angle beta? Phi angle? It is a tangential. Here it is a tangent beta. Here it is phi cap. 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 Clear? Yes. Fine. Let me turn the page here. That is a phi beta. The phi is like this. What is theta? Theta is like this. To indicate the theta, I'm going to consider one more diagram. Here it is Z beta. Here it is Y. Clear? What is theta here? Theta is equal to 0 degrees. Here theta is 90 degrees. Here theta is 180 degrees. What is theta here? Come on, answer. What is theta there? I want answers from your side. What is theta there? What is theta? I want answer from your side. From where you got 90 degrees? Theta range is only from 0 to what? From where you got 270? You are giving our own numbers. Some are giving their own lucky numbers. from where you got 270, from where you got 90. That is what I've been saying with a lot of overaction like this. Doing some all the Surya Namaskaras and all the things, exercises. As your one of your friends saying. Theta range is only from 0 to 180. That is what I have been saying. In all sides, theta is from this side, aage, piche, front side, back side, right side, left side. All the sides, theta is from 0 to 180. Aage, piche, is taraf, us taraf. All the sides. Theta is like this. That I am going to explain nicely with the help of a base of the cone. Nicely, I am going to explain with the help of a base of the cone. What is this base of the cone? Let us say, if I say here the angle is theta is equal to 15 degrees. What does that mean? Here theta is equal to 30 degrees. Here theta is equal to 45 degrees. Here theta is equal to 60 degrees. If I say over the base of the cone, what is the angle wherever you see? 15 degrees. That is the reason why I have taken the base of the cone. Here theta is equal to 15 degrees. Here theta is equal to 30 degrees. Here theta is equal to 45 degrees. Here theta is equal to 60 degrees. Here 15 degrees over the base, 30 degrees, 45, 60. How the theta is better like this? So here it is like this. If you consider the theta is tangential like this, theta cap. 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 So on. Okay, let me go back beta. So here, let us decide finally, what about the directions of unit vectors here? What it is? R is radially outwards. Theta is tangent at this point. Phi is tangential at this point. This is a point P. So R is perpendicular to, so R is like this, theta is like this, phi is like this beta. Okay, let me turn the page here. Now let us do the conversions here. What are the conversions here? You can convert it from r comma theta comma phi to x comma y comma z and vice versa. Let me go back here. This OA is making phi angle with the x-axis. What is the OA? R sin theta, isn't it? So that R sin theta is making, and before that, what is the Z component? This R is making theta with the Z axis. So what is Z component immediately? R cos theta. Z is R cos theta. Then what is this OR beta? Sorry, R sin theta. That means OA. R sin theta is making phi with the x-axis beta. So what happens to the x component? R sin theta cos phi. If I resolve other side, it is R sin theta sin phi. Now I want to do reverse, which is x comma y comma z to r comma theta comma phi beta. Yes, so you can check out r is equal to square root of x square plus y square plus z square. What is this theta? Cos inverse of r by z. And what about the phi? Just take the ratio of these two, you will get tan inverse of y by x. So this is all about the spherical coordinate system beta. Clear? For further visualization, you can take the help of Google Images or YouTube animation videos are also there. I have tried my level best to show you the three-dimensional picture of the spherical coordinate system. Fine. Now observe here. Up till now we have discussed what is called a differential length, differential surface, differential volume, divergence, curl, gradient, Laplacian operator. All these things we have discussed in the knowingly or unknowingly in the Cartesian coordinate system, isn't it? What is the Cartesian coordinate system? X comma y comma z. Knowingly or unknowingly in the Cartesian coordinate system, but the questions are also seen in other coordinates. Anyhow, in the subject what we are going to deal, in that subject other coordinates also important. Fine. So we know this one, we need to derive in the other coordinates, but we will not going to derive that one. I will going to show some idea. Based on that idea, I'll make you to remember easily. Clear beta? Let us start with the first one, the differential length. I'm going to turn the page here. Let us start with the differential length beta. do you write down the differential length for the Cartesian coordinate system? X comma y comma z. dl is equal to dx x cap plus dy y cap plus dz z cap. This we already know. Can we apply the same logic for the cylindrical beta? For the cylindrical, it is rho comma phi comma z. So the dl is equal to d rho cap plus d phi cap plus dz z cap. Can we follow this one? Let us see what is the problem here. So here it is for the spherical coordinate system r comma theta comma phi. dr r cap plus d theta cap plus d phi cap beta. Clear beta? Here you cannot use this logic here because this is distance, this is distance, this is distance. But here this is distance, but this is the angle. Clear? So I cannot add distance plus angle. So what should I do here? Then I should incorporate the distance contributed by that angle. There is an angle here. The angle will going to contribute certain distance. That distance is called arc length. Let me turn the page here. Example number 1. Consider top view of cylinder. What is the top view of the cylinder beta? It is something like this. Here it is X, here it is Y. Z is outside the board beta. Here is the top cylinder top view. And see here. This is a row. And angle here is d phi. So what is the arc length here? Rho into d phi. Let me go back. So if you want to make this as a distance, I should multiply with the rho. So that here it is distance, here it is distance, here it is distance. Clear? Fine. Now observe here further. Example number 2 beta. For the spherical coordinate system. Let me go back. Here there is a distance, this is angle, this is also angle. Here it is x axis, here it is y axis, here it is z axis. Here it is r beta. What is this angle beta? D theta. So what is this arc length? R into d theta. Let me go back. So here you need to multiply with the r. Then what should I do for the last one? Here what should I do? Observe here carefully. For that I will going to draw one more diagram. Example number 3. This is also spherical. Here it is x, y, z, beta. Here it is r beta. The angle which is making is theta and this is r. If I drop this point onto the xy plane, what is this length? We know already. What is that length beta? And what is this angle? Here it is d phi. This one is r sin theta. And what is the arc length here? R sin theta into d phi. Let me go back. So here I need to multiply with r sin theta. Here it is r sin theta. Here I need to multiply with a 1. Here I need to multiply with a 1. 1, 1, 1, 1. So let us develop some standard form here. The standard form here is u comma v comma w. dl is equal to, the scaling factor is h1 here, into du u cap plus h2 into dv v cap plus h3 into dw w cap. This is a standard form. Okay. So what are the scaling factors here? These are h1, h2, h3 are h1, h2, h3 are called scaling factors. For the Cartesian coordinate system 1, 1, 1. For the cylindrical coordinate system 1, rho 1. For the spherical coordinate system 1 r sin theta. So I'll call it as a some standard coordinate system UVW. For the cylindrical, for the Cartesian, it will become xyz. For the cylindrical, low phi z. For the spherical, r theta phi. I'll going to turn the page here. Let me put this one nicely into the box beta here. Here it is U V W H1 H2 H3. Here it is X Y Z. Scaling factors are 1 1 1. Here it is rho phi Z. Scaling factors are 1 rho 1. Here it is r theta phi. Scaling factors are 1 r sin theta. Clear? Yes. So let us try to find out. Let us try to write what is called a differential surface beta. We have done it for the differential length. Let us try to find out the standard form. I'll going to turn the page here. Differential surface. A differential surface is represented with the dA or ds. Here it is dA is equal to I'll write the standard form here. How does the standard form looks? It is a XY plane. Let us take, we'll take the idea from the Cartesian coordinate system. If you are dealing with a Cartesian coordinate system, for the XY plane, the direction is in the Z. Here also for the UV plane, direction will be in the W. So I'll write the first term. H1, H2, du, dv, w cap. The second one is H2, H3, dv, dw, u cap plus H3, H1, dw, dw, du, v cap. This is a standard form. You can easily remember. What happened for the Cartesian, you know. For the Cartesian, the coordinates are x comma y comma z. Scaling factors are 1 comma 1 comma 1. How can you remember this one easily? Multiplication of first two. What it is? Dx dy z cap. Next two. Dy dz x cap. Last two. Dz dx y cap. Next for the cylindrical coordinate system, rho comma phi comma z. Scaling factors are 1 comma rho comma 1. dA is equal to multiplication of first two, rho, d rho, d phi, z cap. Next two, rho, d phi, dz, rho cap. Last two, dz, d rho, phi cap. Next one, r theta phi. Here it is 1 r sin theta. dA is equal to first two, r dr d theta, phi cap. Next two, r square sin theta, d theta d phi, r cap plus r sin theta, d phi dr theta cap. Then what happens to the differential volume? I'll represent something different symbol. Differential volume is multiplication of all the things, isn't it? dx, dy, dz. Here also in the standard form also same story, but along with the scaling factors better. So what are the scaling factors here? H1, H2, H3, du, dv, dw. So this is a standard form. What happens for the Cartesian coordinate system? X comma y comma z, 1 comma 1 comma 1. So what about the differential volume? Here it is dx, dy, dz. What is for the cylindrical rho comma phi comma z, 1 comma rho comma 1. Here it is rho, d rho, d phi, dz. Last one is r theta phi, 1 comma r sin theta. Here it is r square sin theta, dr d theta d phi. Clear, beta? So we have left with the some more operators. I'm going to turn the page here. Let me finish this one so that I can finish the topic number 1. This will give the totality to our discussion. Let me turn the page here. Next, we will going to write the standard form for the gradient beta. Gradient is performed on the scalar field. Output is a vector field, isn't it? Yes. So here is a gradient. Let us consider the scalar field. The scalar field is f of u comma v comma w. I'll represent with the f beta. Yes. The standard form for this one is gradient of f is equal to 1 by h1 into dou f by dou u cap plus 1 by h2 into dou f by dou v cap plus 1 by h3 into dou f by dou w cap. I want to write it for the Cartesian beta. What happens for the Cartesian? We know already. So here it is x comma y comma z. The scaling factors are 1 comma 1 comma 1. Clear? So what happens here? The scalar is f of x comma y comma z is f. So here the gradient of f is equal to dou f by dou x dou f by dou x x cap plus dou f by dou y y cap plus dou f by dou z z cap beta. What happens for the cylindrical rho comma phi comma z? Scaling factors are 1 comma rho comma 1. So here it is scalar is f of rho comma phi comma z. I'll represent it as a f. So what is this one? Gradient of f is dou f by dou rho cap plus 1 by rho into dou f by dou phi cap plus dou f by dou z z cap. Finally, what happens for the spherical beta? Nothing to worry. Just substitution. This makes our life simple. Otherwise, you need to remember all the formulas, which is very big headache. Rho comma phi comma z. The scaling factors are 1 comma rho comma 1. The scalar here is f of r comma theta comma phi. The scalar I'll represent with the f. So the gradient of f is dou f by dou r cap plus 1 by r into dou f by dou theta cap plus 1 by r sin theta dou f by dou phi cap. That is all the story. Clear? We have left with the 3 more operators beta. Let me finish that one. I'm going to turn the page here. Divergence and curl beta, which are defined for the vector field. Clear? So let us consider the divergence. Divergence and curl both are defined for what beta? A vector field beta. Vector field, I will take the standard form. F is equal to fu u cap plus fv v cap plus fw w cap. Clear? So the standard form for the gradient looks like this. divergence of F is equal to 1 by H1, H2, H3. Dou by dou U, H2, H3 into FU plus dou by dou V, H1, H3 into FV plus dou by dou W, H1, H2 into FW. Clear? H1 is missing, H2 is missing, H3 is missing. You can remember that one. And there is some extra factor, 1 by H1, H2, H3 beta. Clear? So what is the curl here? The standard form for the curl is 1 by H1, H2, H3 H1 into U cap, H2 into V cap, H3 into W cap. Dou by dou U, dou by dou V, dou by dou W. H1 into FU, H2 into FV, H3 into FW. So these are the standard forms beta. Now can you write it for the Cartesian, cylindrical and spherical beta? I'll going to turn the page here. So what happens for the Cartesian? Here x comma y comma z. Scaling factors are 1 comma 1 comma 1. The vector f is equal to fx x cap plus fy y cap plus fz z cap. So this we already know beta. Divergence of f is equal to dou fx by dou x plus dou fy by dou y plus dou fz by dou z beta. What happens to the curl beta? Curl is also we know. Determinant of x cap, y cap, z cap, dou by dou x, dou by dou y, dou by dou z. Here it is the fx, fy, fz. Then what happens for the cylindrical? Rho comma phi comma z. F is equal to f rho cap plus fy phi cap plus fz z cap. Scaling factors are 1 comma rho comma 1. So what happens to the divergence beta? 1 by rho into dou by dou rho into f rho plus dou by dou phi into fy plus dou by dou z into rho into fz beta. Then what about the curl? What about the curl? Curl of f is equal to 1 by rho into rho cap, rho into phi cap, z cap. Dou by dou rho, dou by dou phi, dou by dou z. F rho into f phi. Here it is fz beta. Let me turn the page here. For the spherical coordinate system, r comma theta comma phi, scaling factors are 1 r sin theta. Here it is f is equal to fr r cap plus F theta theta cap plus F phi phi cap. Sin theta. Dou by dou r into r square into sin theta into fr plus dou by dou theta into r sin theta into f theta plus dou by dou phi into r into f phi. What about the curl of f beta? 1 by r square sin theta r cap r into theta cap r sin theta phi cap dou by dou r dou by dou theta dou by dou phi fr r f theta r sin theta f phi. Next beta, last operator, Laplacian operator. Let us finish that one also. Laplacian operator. Let us consider the scalar field beta. F of u comma v comma w. I'll represent with the f beta. Laplacian operator is a second order operator. Standard form also will be in the second order form. Here it is. Del square f is equal to 1 by h1 h2 h3 dou by dou u h2 h3 by h1 into dou f by dou u plus dou by dou v h1 h3 by h2 dou f by dou v dou by dou w h1 h2 divided by h3 dou f by dou w. This is a standard form beta. Divided by h1 divided by h2 divided by h3. It is a second order operator. What happens for the Cartesian? You know. Here it is x comma y comma z. Scaling factors are 1 comma 1 comma 1. F of x comma y comma z. I will call it as f. So here it is. Del square f is equal to dou square f by dou x square dou square f by dou y square dou square f by dou z square. What happens for the spherical coordinate system beta? Cylindrical, rho phi z. Here it is 1 rho 1. F of rho comma phi comma z. It is represented with the f. So here it is del square f is equal to 1 by rho into dou by dou rho into dou f by dou rho plus dou by dou phi into 1 by rho into dou f by dou phi plus dou by dou z into rho into dou f by dou z. Last one is for the spherical coordinate system. Let me turn the page. For the spherical coordinate system, r comma theta comma phi beta. Scaling factors are 1 r sin theta. Scalar field is f of r comma theta comma phi. I'll call it as a f beta. So here it is del square f is equal to 1 by r square sin theta dou by dou r into r square sin theta dou f by dou theta dou by dou theta. Sorry, here it is r dou by dou theta r sin theta by r dou f by dou theta plus dou by dou phi into r divided by r sin theta dou f by dou phi. Done. So this will give the totality to our discussion beta. You need to remember this table along with the standard forms. What are the standard forms here? What are the standard forms here? This is the standard form for the differential length. And this is the table you need to remember beta. This is a standard form for the differential surface. This is a standard form for the differential volume. This is a standard form for the gradient. This is a standard form for the divergence and curl. And this is a standard form for the Laplacian operator. Now let us take some questions here. Directly in some of your previous papers, he has directly asked a numerical direct substitution kind of questions here on these things. Here, some of your friends are suggesting me some correction here. Yes, thank you. Here it is Z by R. Thank you. Now let us take some questions here, beta. Anyhow, later also in our subject we're going to use these formulas again extensively. But for the time being, just let us take some sample questions here. Here is a question. The scalar field in certain region is given by r square sin theta cos phi. Find its gradient at 1 comma pi by 4 comma pi by 4. Yes. What should I do, beta? He is asking us to find out the gradient, isn't it? Here is a solution. Let us say the scalar is r square sin theta cos phi. Clear, beta? So it is in the spherical coordinate system, beta. Yes. So what is the gradient formula in the spherical coordinate system? I have already given. So what is the gradient of f beta? Is dou f by dou r cap plus 1 by r into dou f by dou theta theta cap plus 1 by r sin theta into dou f by dou phi phi cap. So what is the gradient of f beta? I am directly writing 2r sin theta cos phi r cap plus 1 by r into r square into cos theta cos phi theta cap. Differentiation is with respect to what beta? Phi, last one. So here it is minus of 1 by r sin theta is equal to r square into sin theta into sin phi cap. So here it is gradient of f is equal to 2r sin theta cos phi r cap plus r cos theta cos phi theta cap minus r into sin phi cap. Just substitute at a point at r comma theta comma phi 1 comma pi by 4 comma pi by 4. So here it is gradient of f is equal to 2 into 1 into 1 by root 2 into 1 by root 2 into r cap plus 1 into 1 by root 2 into 1 by root 2 into theta cap minus 1 into 1 by root 2 into phi cap. So this will become finally gradient of f is equal to r cap plus 1 by 2 theta cap minus 1 by root 2 phi cap. Clear, beta? Let us take one more question. One of your friend is asking, is there any shortcut to remember this one? Beta, these are the things what I have given is a shortcuts. Otherwise, total how many formulas you need to remember without these standard forms? Differential length, differential surface, differential volume, divergence, curl, gradient, Laplacian. 7 formulas in the 3 coordinate system. That means 27 formulas you need to remember. But if you remember these 7 standard forms, you can get the 27 formulas, 21 formulas. These are the start cuts only what I have given. Otherwise, this will be a headache for us. Let me turn the page. We'll have one more question, beta. This was one of your gate question asked in EC paper. Find value of N for solenoidal field. A is equal to 4 into R to the power of N R cap. Find the value of N for the solenoidal field. This is a story. Yes, beta. It is a spherical coordinate system. And it is said that it is a solenoidal. What is the divergence formula in the spherical coordinate system? Solenoidal means divergence is 0. Divergence of A is equal to 0. What is the spherical coordinate system divergence formula, beta? Here it is 1 by r square sine theta. You will get it by the practice into dou by dou r square sine theta into AR plus dou by dou theta r sine theta into A theta plus dou by dou phi r into A phi, which is equal to 0. Here this is what is given, it is having only R component. So here it is, this part is 0. This part is 0, beta. This will become, this implies, or other words, 1 by r square sine theta dou by dou r square sine theta into AR. What is AR? 4 into r to the power of n is equal to 0, beta. Bring the constants outside. 4 sine theta outside, beta, divided by r square into sine theta dou by dou r to the power of n plus 2 is equal to 0. Here it is 1 by r square into dou by dou r, beta. 1 by r square into dou by dou r into r to the power of n plus 2 is equal to 0. So here it is 1 by r square n plus 2 into r to the power of n plus 2, n plus 1, beta, is equal to 0. Here n plus 2 is equal to r to the power of n minus 1 is equal to 0. This happens only when n plus 2 is equal to 0, n is equal to minus 2, beta. N is equal to minus 2 is the answer, beta. Let us have one more question, beta. I'll going to turn the page. This was DRDO question. Scientist entrance test. Before 2010, there used to be a exam called scientist entrance test. Nowadays it is, they are recruiting through the gate itself. Everything is through the gate. Here is a question. If f of rho comma phi comma z is equal to rho cap plus rho Sine square phi cap minus z cap. Then which one of the following is true? Options are given beta. Option A, divergence of f at phi is equal to 0 is less than divergence of f at phi is equal to pi by 2. Option B, divergence of f at phi is equal to pi by 4 is equal to divergence of f at phi is equal to 0. Option C beta. Divergence of f at phi is equal to 0 is greater than divergence of f at phi is equal to pi by 2. Option D, divergence of f at phi is equal to pi by 4 is equal to 2 times the divergence of f at phi is equal to 0. So ultimately what you need to find out beta here, you need to find out the divergence of the given vector and you need to apply the 3 limits here. What are the 3 limits here? Phi is equal to 0 is one limit, phi is equal to pi by 2, other one is phi is equal to pi by 4. Yes, so find out the divergence. It is in the cylindrical coordinate system. So what is the divergence of f is equal to 1 by rho into dou by dou rho into f rho plus dou by dou phi into f phi plus dou by dou z into rho into fz. So what is this one? 1 by rho into dou by dou rho into rho plus dou by dou z into dou phi into rho into sine square phi plus dou by dou z into rho into minus z. So here it is 1 by rho into rho it is rho square which is 2 rho plus rho into 2 sin phi cos phi minus rho which is 1 by rho into 1 plus rho into 2 sin phi cos phi which is equal to 1 plus sin 2 phi beta. Yes or not? So just substitute those limits beta. I'll going to turn the page. So here divergence of f is equal to 1 plus sin 2 phi beta. Yes or not? So just substitute those limits and give me the answer. at phi is equal to 0 beta. What is the divergence of F? 1 plus sine of 2 into 0. It is 1 plus 0, which is equal to 1. Yet phi is equal to pi by 4 beta. Divergence of F is equal to 1 plus sine of 2 into pi by 4 beta, which is 1 plus 1, which is equal to 2. At phi is equal to pi by 2 beta. Divergence of F is equal to 1 plus sine of 2 into pi by 2, which is 1 plus 0 is equal to 1 beta. So let me go back. Which one is answer? Option D is answer beta. At pi by 2, pi by 4 it is 2. At 0 it is 1. Option D is answer. So this completes our topic number 1. How many marks are expected from the topic number 1? Minimum 1 to maximum 2 marks. Every year there is a one question from this vector calculus. 1 mark, 2 marks is it's a gravity. Try to understand the 1 mark gravity, 2 marks gravity. It's not your university exam, competitive exam. 1 mark will also be very crucial thing. You cannot just say that only 1 mark I leave it. Only EMF 4 marks I leave it. Signals 2 marks I leave it. Digital 3 marks I leave it. Don't be under that impression. Understand the gravity of each and every mark in your competitive exams. Clear beta? Fine. Now we need to, before going into the topic number 2, what is the topic number 2 beta? Electrostatics. Isn't it? Before going into the topic number 2, let us have some story of electromagnetic theory. What we're going to see is the EM phenomena, undoubtedly. But what is the origin for the entire EM phenomena? From where it will going to start? It will going to start from the charge. If you have a charge, what is there around that one? Electric field is there. If I keep the charge under the motion, charge under the motion constitutes or gives the current, and the current carrying conductor will have a magnetic field around it. Okay. On the other hand, I'll consider accelerated and deaccelerated charges. When you have accelerated and deaccelerated charges, there is a possibility for both electric and magnetic fields, which is called EM phenomena. Let me put it onto the paper here, what I mean to say. Number 1, there is a charge here. If you have a charge, what is there around this one? There exists what is called an electric field. Okay, so if there is a charge, around the charge there is an electric field beta. So what it is? How the charge is? Charge is at rest. Charge is at rest. What kind of field exists around this one? There exists what is called electric field. Only E field exists. Number 3. Do you apply any supply? No. There is no supply here. No supply. Number 2 beta. If I keep the charge under the motion, how can you keep the charge under the motion? By applying the external supply. Okay. So I'll keep the charge under the motion. Where I am considering the charges? As far as our subject is concerned, we are considering the charges in the conductor or on the conductor. Inside the conductor, on the surface of the conductor. Isn't it? So there is a conductor here. I am applying the constant supply beta. If I apply the constant supply, what happens? Charges will move with the uniform velocity. Like this. How can the charges can move? Externally, I need to apply the electric field. That we're going to understand with the help of a Ohm's law. Okay. So when the charges start moving, they are covering equal distances in equal intervals of time. There exists what is called a magnetic field around it. What exists is a magnetic field. So this electric field is giving magnetic field beta. So both electric and magnetic field exist, but there is no EM phenomena. There is no coexisting mechanism. So what are the charges here? Charges are moving with uniform velocity. Both E and H exist beta. Both E and H fields exist, but no EM phenomena. No EM phenomena. What kind of supply is needed? Which I am not showing. Actually, I need to show the supply like this, which I am not showing here. What kind of supply? Constant supply beta. Number 3 beta. I'll consider accelerated and deaccelerated charges. How do you get the accelerated and deaccelerated charges? For accelerated and deaccelerated charges, one should have time varying supply. For the positive cycle, they get accelerated. For the negative cycle, they get deaccelerated. Let me show you symbolically like this. For the first second here, next second here, third second, they get accelerated like this. So if this is the case, there exists both electric field as well as magnetic field. There exists both electric field as well as magnetic field, and there exists an interplay between them, which is called EM phenomena. So how the charges are here? Charges are accelerated. Charges are accelerated and deaccelerated. What is this one, beta? Both E and field exist. Both E and H fields exist. And there is a EM phenomena, beta. There is EM phenomena. And what kind of supply is this? Time varying supply. So this is what this is called electrostatics. This is magnetostatics. And last one is the time varying fields and Maxwell's equations. And Maxwell's equations. So this is a story. This is a storyline of the things what we're going to see. What is the nature of this electric field? That we're going to see by the Coulomb's law. Different types of charges, point charge, line charge, surface charge, volume charge. And we're going to see the different techniques, potential, Gauss law, Poisson's equation, method of images. And how this is Ohm's law, Biot-Savart's law, different currents. And then how this is happening, Faraday's law, generalized Ampere's law. So the next couple of lectures, what we're going to do, I have revealed here. This is a story of electromagnetic theory. This is a storyline of electromagnetic theory. And the underlying in this process will also define what is called a Maxwell's equations. So this is a story I have revealed. Generally, after knowing the story of some movie, you do not enjoy, isn't it? If you know the storyline, you will miss the thrill. But here something different. There will be a twists, there will be a turns, and there will be a bends in this subject. And you'll surely will going to enjoy. And every scene looks like a climax. Okay, fine. Let us start with the topic number 2, beta. I will not give all the booty definitions that electrostatics is a study of charge which is at the rest and all that story. Fine. Let me turn the page here. Let us start with the topic number 2. Is a electrostatics. So obviously, whether you like it or not, you have been learning this one from your childhood. Childhood means in from your high school physics. Your electrostatics will going to start with what is called a Coulomb's law, isn't it? What is the Coulomb's law, beta? You all are aware of this one, but my interest will be in the vector representation of the Coulomb's law. Coulomb's law. Yes. What is the Coulomb's law here? If there are two charges are there, isn't it? This is how it starts your physics. If they are like charges, they'll repel each other. If they are unlike charges, they'll attract each other. And what is the force of attraction or repulsion between them? Is proportional to the product of the charges, and the force between them, and it is inverse proportional to the square of the distance between them. Let me consider the two charges beta here. Here it is Q1 beta. Here it is Q2. Here it is the origin. Clear beta? Here with respect to the origin, this is located at R1. This is located at R2 with respect to the origin. Here it is R1. Here it is R2. If I am considering these two charges to be a positive charges, so what happens? Q1 will going to exert the force on Q2 in which direction? And Q2 will going to exert the force on Q1 in this direction. Yes, let us try to find out the force on Q2 due to Q1. It is like this. I'll call it as a R12. Here it is a vector, unit vector. R12 cap beta. What is the force acting on this one? Line joining 2 points like this. Here it is F12. It is a force on. It is a force due to. Force on second charge due to first charge. Yes. Suppose if my charge is somewhere here, what would be the force on this one? Line joining 2 points. This is a force direction. If my charge is somewhere here, the force on this one would be line joining 2 points. Clear? Yes. Fine. Then I want to write this vector R12 beta. What is this R12 vector? Let me go back to your small basics of vectors. Let me go back to the basics of the vectors. You would have learnt about addition of vectors in your high school. If there are two vectors are there like this example. If the tip of one vector is touching the tail of other vector, here it is a A, here it is B. Then what is the resultant? The resultant is tip of one vector is touching the tail of other vector. Then the resultant will be from tail to tip. Here it is A plus B beta. Okay, I'll apply the same logic here. Here is a vector beta. Here it is R12 vector. Here it is R1 vector. Then what is this one beta? R2 is equal to R1 plus R12. What is this R12? Is equal to R2 minus R1. Just forget about all this story, vector, all the story. I want to find out the force on second. Remember like this. I want to find out the force on second charge due to the first charge. If I want to find out the force on second charge due to the first charge, what I need to do? I need to take R2 minus R1. If I want to find out the force on first charge due to second charge, I need to take R1 minus R2. Here it is R12 vector is equal to R2 minus R1 beta. Here it is R2 minus R1 beta. Then what is this unit vector beta? R12 cap. Vector by its magnitude. R12 vector by its magnitude. If I do not put a cross, it indicates the magnitude. The other way of writing the magnitude is, you can just put like this. R12 by modulus. Clear beta? Okay, let us see the law. What is that law? I'll going to turn the page. What is the law beta? The magnitude of F12 is proportional to the product of charges and inverse proportional to the square of the distance between them. Clear? And what is the proportionality constant here? F12 vector is equal to 1 by 4 pi epsilon Q1 Q2 by R1 magnitude square. So F12 vector is equal to Q1 Q2 by 4 pi epsilon R12 magnitude square into R12 cap. So this is a law. Units are newtons beta. For our convenience, you can write what is this R12 vector? It is R12 vector by its magnitude. You can substitute there. So what you are going to get? R12 is equal to Q1 Q2 divided by 4 pi epsilon R12 vector by its magnitude Q. Remember, it is not, the force is not varying as a 1 over the distance cube. It is only for the mathematical convenience. Clear, beta? And what is this epsilon here? Epsilon here is equal to epsilon naught epsilon r. This is called permittivity. What it is? Permittivity. And what is this epsilon naught beta? Is 1 by 36 pi into 10 to the power of 9 farad per meter. This is called absolute permittivity. And here mu r is equal to 1 for the air, and it is greater than 1 for other than air. Yes. So here epsilon r is called relative permittivity. This is a medium parameter beta. What it is? Medium parameter. I'll talk about this one later. It is relative permittivity. Clear? So let us take one question here, beta. I'll going to turn the page. It is a very simple thing. You have been learning right from your childhood, but you must be careful about the vectors here. That's all it is. You know, everyone know this about this one. Let us talk about what is called. We'll take one question. 2-point charges. Q1 and Q2 are located at 3 comma 0 comma 0 and 1 comma 2 comma 0 respectively. Anyhow, find the relation between Q1 and Q2 such that X and Y components of total force, X and Y components of total force on test charge Q0 placed at 1 comma minus 1 comma 0 are equal. Options are given. Q1 by Q2 is equal to 5 root 5 by 9. Option B, Q1 by Q2 is equal to 9 by 5 root 5. Option C, Q1 by Q2 is equal to 5 root 5. Option D, Q1 by Q2 is equal to 9. Yes, beta. We'll solve this question after break. We'll take 20 minutes break. Horror movie. Yeah. Everyone is giving their own interpretation. Horror movie. Yeah. No, these are the characters only. Okay, just for the effect purpose, I have said it like a story. But this is a gist of the electromagnetic theory. So this is what we're going to do in electrostatics, magnetostatics. Just to create some interest, to create some fun, I've said it like a story. Fine. Anyhow, we'll go for 20 minutes break, beta. After that, we'll continue. In the break, just think about it.